Hello, my name is Malvika Gupta, and today we are going to discuss the last collision resolution technique in open addressing, double hashing. So we'll be discussing about what is double hashing. We have already discussed about quadratic probing and linear probing, and there we have find out that we have a problem called clustering in the case of both linear probing and quadratic probing. In linear probing, clustering problems are called the primary clusters, which linear probing forms, and it is more in numbers. But it, when we move to quadratic probing, it little bit lessened down, but still the problem of clustering exists. So that problem can be resolved using the concept called double hashing. In double hashing, we use the concept like this. So if you see the formula, it is like this: H1 key plus I multiplied by H2 of key and modulus m. So m is the size of hash table, and we all know that the hash table size should be greater than or equals to the number of key elements. Whereas if you remember in the linear probing, it is this condition satisfied. But if in case of quadratic probing, we have decided to take the size as the square. I mean double the size of the table. If the size is 7, then we used to take the size as 14, because there we are finding the location, the empty slot quadratically, right? It's after doing the square of the number of collision. If suppose this number of collision is 1, then the square is 1. If the number of collision is 2, then your next empty slot would be such that 4, 2, because 2 square is equal to 4. Now, this is the formula for double hashing. Here we are, if you can see, we are doing hashing for 2 times. This particular one is for the normal hash function, your original hash function. As you can see this is the original hash function. And this part is to find the new empty slot, to find the empty slot. All right. I will decide that how much of the shift we have to take. The number of collision is represented by this I. Okay, so this H2 key is always given to us, and H2 key and M are relatively prime, so that we have the maximum of the chances that we can find the empty slots. Most importantly, this double hashing, as in the case of quadratic probing, we know that there might be the chances that we could not be able to find the empty slot if the size of the hash table is equal to the number of elements. But in case of double hashing, the key values are more uniformly distributed in our hash table. Okay, so this is what we are going to discuss. This is all about double hashing, how it is important, and what we will do in this. So if I go, we have this question. Let me explain this with you with the help of an example. I wanted to keep it in the hash table. So suppose my hash table size I am taking as 7. Wait, let me create a hash table. 1, 2, 3, 4, 6, 7. So it will be 0, 1, 2, 3, 4, 5, and 6. So my M is 7, and my hash function. The original hash function is, H1 key is key mod 7. It is already given. You know that if this condition, see, always remember this portion will be used when I have found a collision for storing the value. If there is no collision, then directly I can put my value over here, because I will become 0. If I become 0, so you can understand that if I is 0, then this entire portion becomes 0. So there is no use of this one. But if the collision occurs, then this function will come into the picture. So H2 key, H2 hash function. Now you remember, now you can understand this fact that if suppose I have 7 keys, so if the collision has occurred and I have to use that H2, I mean the second hash function I need to use, it means out of 7, one of the slot has been filled, and rest 6 are the only slots which are remaining to be filled. So what I will do, so H2 hash function will be what? It will be 6 minus key mod 7. This is going to be my hash key mod 6. Sorry, this is going to be my hash function. Is it okay? I hope this is clear to everyone, because h2 key is will come into the picture when once we have used this portion, right? That first of all, if there is no collision occur, then h1 key will work. If there is a collision, then we have to find the extra slot or empty slot, and to find that empty slot, what we have to do, we will be using this h2 key. And why we have taken the value 6? Because out of 7, one has already been occupied. That is why collision has occurred. So in the remaining 6 slots, we need to identify the empty slot to store my key value. Right now let's come to this one. Like suppose if I wanted to store this 49, so I can directly go. My function is hash key I h1 key plus I multiplied by h2 key and mod, right? So h1 key is what? H1 key is key mod 7. So 49 mod 7 is 0. So I can store this value over here. Now comes the next value 63. But now you can see 63 mod 7 is also 0. I cannot store this value in this particular position because there is a collision. So what I can do, I will find out my value is h1 key. I have searched, it becomes 0 plus. If I write over here for 63. So h1 key is 0 plus I is 1 multiplied by h2 key is what? 6 minus key mod 6. So 6 mod 6, how 63 mod 6, how much the value will be? So it will be 3. So 6 mod 6 minus 3 mod 7. So if you write 0 plus 3 mod 7, it will become 3 mod 7, then it will be 3. So you can store this value at this position. I hope this is clear to everyone, right? So let's take the next value, 56. 56 is again 0. I cannot put this value over here. So what I will do, again I will search for the, so what, 0, h1 is 0. Now 6 minus, because this is occupied, so I have 6 empty slots remaining for me. I have nothing to care about this particular block. For me, after the 0th position, rest of the blocks are empty. 6 minus 56 mod 56 mod 6, and the entire one is divided by mod 7. 0 plus 6 minus, how much it is? 2, right? Then mod 7. So, and there is also 1 multiplied by collision occurs, right? So because I value of I is 1, because collision has occurred only once. 6 minus 2, it is 4. So 4 mod 7, it will be 4. So your 56 will be stored at this particular position. Again, we will do for 52. If I see for 52, then 52 mod 7, how much it will be? It will be 3. Now you see, at third position, I have 60, right? So what again? Again, a collision has occurred. So we again will apply the same formula. So here I am going to write 3 plus. Now we'll have to check whether it is okay or not. Because 52 mod 7, 3 for the original one, h1 key, it will come 3. If you want, I can write it over here also. For 52 equals to h1 52 plus I multiplied by h2 52. Let's see. h1 52 means 52 mod 7. So it will be 3 plus, at third position, there is a collision. So it means that 1 multiplied by h2 6 minus 52 mod 6, and the entire is divided by your 7. So this is 3, 1 multiplied by. Now check for this one. 6 minus, how much it will be? It will be 4. 6 minus 4. So it will become 6 minus 4 is 2. 3 plus 2 mod 7. It means 5 mod 7, it is 5. So you can store the value over here directly, which is 52. Next value is 54. If you go for 54, then you can see, if I write 54 mod 7, how much it will come? 5, right? Now you can see that 5 is already occupied. I cannot put any value over here because this is not an empty slot. So what I need to do, I again have to find out the position. So it will be 5 plus 1 multiplied by 6 minus, if you write 54 mod 6, right, modulus 7. So how much it will be? 5 plus 1 multiplied by 6 minus, it's 6, so it will become 0, this portion, fifth position. But now at fifth position, we have 52 already stored. It means the collision has occurred for second time. So what will happen? We will put 2 over here. Okay, the collision has occurred for the second time, so we have to put value 2 in this place, right? So we will keep on solving this value like this. I hope this is clear to everyone, right? Then we need to search for the value that yes, exactly this is the value which is coming for us. So we can find out. I hope this is clear. Yes or no? I mean, it's clear to everyone because we need to search for this one. Okay. So how you can do this one? See, if I solve this one for you, then it will be like this. Let's solve this one. I am solving it over here. So it's the next value is 54. I am writing it over here. 54, 54 mod 7. If you write it, it will be 5. So at fifth position, we have a collision occurring over here. So I cannot put my value over here. So 1 multiplied by 6 minus 54 mod 6 mod 7. 5 plus 1 multiplied by 6 minus 6 9 54 0 mod 7. So it is 5 plus 1, 5 plus 6 mod 7. It means 11 mod 7, which in turn will become 4. Now if you see for 4, at fourth position, we have a collision here. So what we will do, we will again do one thing, just only we'll change the value, the number of collision has occurred 2. So we'll place it 2. Here it will become 12. 12 plus 5 will become, if I write it here, 17 mod 7. What is the value? It will come 3. So if you check for 3, you can find out that yes, here again the collision has occurred. So again, this collision has occurred for the third time. So I will write 5 plus 3 multiplied by 6 minus 54 mod 6 modulus 7. So if I write 5 plus 3 multiplied by 6 minus 0 mod 7, it is 5 plus 18 mod 7. So it will be 23 mod 7. 23 mod 7, it means the value is 2. So let's check whether it is yes. At second position, I can put this value 54. Right? Now check for 48. If I can put my value 48. So if you check for 48 mod 7, 48 mod 7 is 6. Now if you see at sixth position, we have an empty slot, so we can put it over here directly. So that's how we have put it. Now you can find out there's no cluster forming in this one. So this is all about the double hashing, and this video is in the continuation of the collision resolution technique. So now you can check, these are the references through which you can go on this one, and thank you.